So hey everyone, welcome to Student Algorithm. So in this video we're going to discuss about the two major topics where we'll be covering about the modulo expression and a power b. In modulo expression and a power b, these are the major problems where we'll be covering, from brute force to the optimal approach. So in this modulo expression and the a power b, it's a basic intuition where we'll be using this kind of problems in another problems of the bit manipulation. So first, what is modulo expression? So modulo expression is nothing but, see, let's consider one example over here. Just a minute here. So let's take, as I said, we will be having 32-bit registers or memory. Whatever the number you will be storing, it will be in the form of 32. That means you will be storing 3 power 31 minus 1 numbers. So what about if these numbers are greater than this? For suppose I will take 2 power 32. How can I store this? I cannot store this in this 32-bit register, right? So to overcome this problem, what we have done is we introduced the modulo expressions. This modulo expression is nothing but whatever the number which is greater than this, that will be giving the reminder when it is divisible by something number. For suppose, let's take 17. Here 17 modulo 5. Modulo is nothing but it gives you reminder. When you divide with 17 when is divisible with 5, it will be giving you reminder as 2. So whenever the huge numbers, the greater numbers which cannot be fit in the 32-bit register, we will be dividing that at particular number. So there we will be coming across a modulo expression. For suppose, let's take we have the number like 2 power 8 into 2 power 8 into 2 power 8, where we can fit this number. It's highly impossible to fit this number in 32-bit register. So there will be, what we'll be doing, we just taking out the reminder, right? Got it? See, one more thing I want to say is that why do we use modulo? Why we do use modulo is nothing but to prevent the overflow. Overflow means, as I said, that in 32-bit register we cannot fit 2 power 32. We cannot fit 2 power 32, right? So to avoid this overflow, we will be using this modulo. So in generally, while solving some DSA problems or in competitive programming problems, they will be giving you in a question that we need to divide 10 power 9 plus 7 to overcome this overflow. So the thing is, let's consider why we'll be using the modulo, right? For suppose, let's take an example, like I took 10. Okay, so 10, I'll be dividing everything using 10, right? So let's take 25, let's take 29, and let's take 30, right? So 25 modulo 10 is nothing but 5. It gives reminder. 29 modulo 10 is nothing but 9. 30 modulo 10 is nothing but 0. Whenever you perform the modulo operation, what you can observe here, you will be seeing these numbers resulting less than 10. So whenever we perform the operation, so when we divide that with 10 power 9 plus 7, so that results to less than 10 power 9 plus 7, which fit in the 32-bit register. That's why we'll be performing the modulo operation using 10 power 9 plus 7. Right, I hope you got this. So next, let's consider if we had the huge numbers like 2 power 32 plus 2 power 32, how we need to take the modulo. There are some conventions. Generally we'll be using this in the competitive programmings when we need to perform certain operations on large numbers. Like let's take a plus b. A plus b mod m is equals to a mod m plus b mod m mod m. We need to first take the modulus of this, and then we need to take the modulus of this and entire modulus of this. So this is general convention that we need to follow. And similarly with subtraction and multiplication. So generally we won't prefer this division because there are certain rules that we don't need to go that much deep into that. When you give division, you try to you try to convert that into multiplication, so, and then perform it, right? Now let's move into next. Just a minute, I think something went wrong with this. So yeah, now let's look into the brute force solution of the a power b. A power b is nothing but like for suppose let's take a power b, right? So how can you write this a power b? A multiplied b times a into a into a into so on. How many times? B times. This is the simple thing that we can write over here, right? So now in this, what we have took is generally we are multiplying, right? So that will be in the largest integer form. That's what we will be taking this as long. So when we'll be storing this result in this result variable, so what I'm doing is I will be iterating from 0 to and less than b, I mean b times, right? I will be iterating this a to the b times and multiplying that result and doing modulo operation. You can perform this in this way as well. Mod m into a mod m whole mod m. Right? So this is how you're gonna consider it, right? Now what we are going to do is, this is how the basic programming look like. There is no explanation to it, right? So now let's look into the bitwise approach. So we have see, if a is equals to and b, for smaller numbers that's fine. What about if the numbers are huge? What about if the numbers are in the form of 3 power 2 power 32 whole power 2 power 32? We cannot write that in the bit manipulation, and we cannot loop over 2 power 32, right? This is impossible. It takes huge time. We cannot get the answer. So what is the optimal approach for this? So the optimal approach is nothing but it's about using the bitwise approach. So now let's consider the example of 3 power 13. Right, I'll be explaining here itself, right? So now let's consider the example of 3 power 13. In 3 power 13, how we can write 3 power 13 as? 3 power 13 as 8 into 3 power 4 into 3 power 1, right? So what we are doing, we are writing these powers in the form of 2 powers. I mean this is 2 power 0, 2 power 2, 2 power 3. What we are supposed to do, just neglect this. We are writing this b in terms of 2 powers, right? So this is how we can write and we can represent over this problem. So now let's look into this, how we can approach this, right? So now here what we have done, we just multiplied this everything, right? For suppose we have 3 power, what we have done, 3 power 13, right? In 3 power 13, how can 13 will be written as? It will be written as 1 0 1 1 or 1 1 0 0, right? It will be in the form of 1 1 0 0. So that we can written in the form of 8 4 1. I mean we can divide this into 3 power 8 into 3 power 4 into 3 power 1. So firstly we try to multiply this and then this and then this and store it in some variable. So how we are going to do that? So now this is the main thing over here. So I'll be explaining you the approach. We got 2 power 13 over here, 3 power 13 over here, right? Here b is equals to 13. the binary representation of the 13 is 1101, right? So in this, what I'm trying to do is that, so first we need to do AND operation with 1. So AND 1, what I'm getting over here, 1 1 0 1. It is not equals to 0, right? If it is not equals to 0, what I'm supposed to do? I am supposed to multiply that result into A, right? So in that result is equals to 1, right? So what I will be doing is, I will be taking this 1 is nothing but result into A mod n. Result is nothing but, we have here result is equals to result into A mod n, right? So firstly the result will be 1 and A will be 1. So what I will be doing is result into A. Result is B, I mean this. So result into A is nothing but 3, result is nothing but 1. So that will be equals to 3, right? In next loop, B is shifted to right. So now the B will be becomes, after this, now B becomes, I'll be writing here 110 as it shifted right. After that, I will be checking this, I mean B and 1 110. It is not equals to B, right? So what I'm trying to do, so now I'm just directly multiply this A. So what I'm trying to do is, I'll be multiplying that with A into A. Now A becomes what? A became 3 square, right? So now now A become what? 3 cube. Now again B shifted to the right. Now it becomes 1 1. So now it will be checking whether it is a set bit or not. It is a set bit. After it got into set bit, now we have the result is equals to 3, right? It will be multiplying with A. So what will be it becomes 3, result is equals to 3 into 3 square, 3 cube. So result into A. So in this way, everything will be performing. What we are trying to do is, we are trying to perform the operation over here. Like if you have the set bit, we'll try to multiply that over here. If you have set bit, we are trying to multiply that over here, which becomes 3 power 4, right? So here it will be 3 power 4. Again we'll be having set bit, that will be multiplying with 3 power 8. So in this way, we are trying to solve this problem. So this is all about today. So I hope you'll be showing some love. Thank you.